This is Michael, Bryan, and Lee's final project submission for CIS414 Advanced Object-Oriented Programming with Design Patterns. This is our game Meow Rush, and this will be a technical demonstration video where I discuss each of the design patterns we implemented and where we implemented them. Now, let's get started. The first pattern we'll be discussing is the decorator pattern. As you can see in the bottom left, I have a specific move type, in this case a double jump. This can be changed to something else, like a triple jump, or a glide. Decorator pattern handles the noises these jumps make, their behaviors, everything else about them. Let's see, use the teleport here. And then the proxy pattern is used to turn a simple white square into this wind sign, which is a little bit more elaborate than what is initialized when the game starts. The next two patterns we will discuss are the state pattern first. As you can see down the bottom left with the debug log, there is a grounded state and an air state. In the grounded state, you use the grounded jump when pressing spacebar. And in the air state, you will use your special move type, whether that's a double jump, or a teleport, or a triple jump. We also use the singleton pattern to make our platform score. In our game, we use the singleton pattern to ensure that there is only one instance of the score manager, and that is accessible across all of the different screens and game states. This helps us to track player score more consistently, as there is a reset in this game. We also implemented the strategy pattern to resolve jump behavior. It has the exact same functionality as the decorator pattern, but it can just be toggled as to what pattern you use in the menu. We also used a factory pattern to determine the actual behaviors you get out of different strategy selections. And a factory pattern is used to determine what enemy types spawn where, whether it's one of the smasher enemies, a saw blade, or a ghost enemy. Enemy behavior is determined by the mediator pattern to reduce the dependencies between objects. Instead of enemies directly communicating with each other and interacting, we use an enemy mediator to handle all of their communications. We implemented object pooling for our platforms. These platforms are randomly generated from an object pool, and after a set period of time, they will disappear. And then, if the tower is high enough, it will reuse them. But currently, the tower is only set to 25 because, quite frankly, I can't climb that well. And typically, I'm going to get the game over screen before I need to worry about the object pool running out. Speaking of game over screens, we use the observer pattern, which allows objects to subscribe to events and notify them when events occur. For example, we use it to trigger game over screens when the player drowns or runs into an enemy, as I did. We also implemented the command pattern such that whenever the player moves, this shadow cat enemy will attempt to mimic that movement and attempt to pursue the player. Though when you're facing it, it will back away, but when you turn your back, it will pursue. And last but not least, we also have the adapter pattern implemented into our game. For a save and load function, the adapter pattern itself doesn't do the saving or loading, but it instead saves to a CSV. As we can see when we press the P key, it saves. And then we can press the L key to load various areas. Again, the adapter pattern doesn't actually do the saving, but it could be used to save to other file types if we so choose. Again, we save down there, load it, and it brings us right back. These are all of the patterns we have implemented into Meow Rush. Michael implemented the strategy, decorator, proxy, and the state pattern. Lee implemented the object pooling command and adapter patterns, and Bryan implemented the singleton, observer, and mediator patterns. Hope you liked the video.